Hi everyone. Welcome back to Dave's Math Channel. I'm your host David Tear, and today I'm just going to give you sort of a map of first year calculus. So this is more kind of an overview. I'm not going to actually give you any particular calculus lessons in this video, but I'm kind of going to show you what's involved in learning at least first year calculus. Calculus is a very big subject. I mean, I've had about 10 years of calculus. There's a lot of calculus you can learn. I think undergraduate calculus, usually undergrads learn about 3 years of calculus if they're going into a STEM field. First year involves calculus functions of a single variable. Second year you learn multivariate calculus, calculus involving functions of more than one variable. That involves vector calculus, and then third year, I guess you learn things like differential equations and how to solve them, and that's just undergrad. And then if you want to go further, then there's a lot of very advanced topics in calculus, which I'm not going to go into right now because I've already probably scared you enough. But um, anyway, I just want to show you some maps. This guy, there's a website or there's a YouTube channel I really love. I can't remember who runs this channel, but he has all these different maps of different scientific fields. He must have about a dozen of them. This is just one of them. This is called the map of mathematics. And this, I'm not going to go through this, but this has pretty much every kind of math that anybody could ever want to study, pretty much. And calculus is just a very small portion of this picture. Let's see, where is it? Um, Senior. Oh yeah, it's in the bottom. If you look at the kind of dark purple segment, the bottom left, changes. So calculus involves changes. So that's really calculus in the bottom left, and I guess that falls under pure math. Although there's a lot of applications of calculus. Like I said, I'm not going to go through this picture, but there's other maps you can make. So that was all of math. Here's a map of calculus. And I might as well go through this one. So what do we learn when we learn? This is just first year calculus, by the way. And so I think we start at the top. So if you notice that the top portion says differentiation, the bottom portion says integration. Integration is the opposite of differentiation. But differentiation is easier than integration. That's why I usually learn differentiation first. And what do you first learn? Well, kind of what I'm teaching you right now, limits. So if you notice right above differentiation, there's stuff on limits, how to define derivatives in terms of a limit, what a limit is. I guess they don't go into that in this slide. But then once you learn all that, that's kind of the hard part, actually. Learning, about limits and then how to define derivatives in terms of limits. That's kind of hard conceptually because limits are a little complicated. They involve an infinite process. You have to think of infinitesimal quantities and all that. But once you have all these definitions down, then you can derive rules. And then once you have these rules, this is in the top right. Then you can derive all these rules for differentiating, for computing the derivative of pretty much any kind of function you can think of. Elementary functions, anyway. Once you have these rules, it becomes very easy to do calculus because you just apply the rules. It's sort of formal. It becomes kind of formal calculus where you're given a function and you know the rules for differentiating, and so you just do it. You just apply the rules and you can evaluate the derivative at points. Then it gets kind of easy. Uh, and then once you've done that, that's sort of the easy part. And then you learn how to apply derivatives. That's what's on the top left. And then you do things like second derivatives. It turns out the second derivative is very important as well. And you can use it to analyze functions. You can find maxima, minima, all that stuff. That leads to some very useful applications. And then once you've learned all that, then you learn about integration. And again, when you first learn integration, it's kind of complicated. You have to learn what an integral is, and it has a definition, and again, involving an infinite process where you're kind of approximating areas under a curve. But then you learn the fundamental theorem of calculus, which is really that integration is just the opposite of differentiation. See, we already have rules for calculating derivatives. We just apply those rules in reverse to get rules for integration, which isn't too bad. Although a lot of times, evaluating integrals is kind of tricky because it's not so easy to go backwards. You have to apply a lot of tricks. It's kind of fun though. It's kind of like a puzzle, I think. So I kind of like integration. It's not that hard. I think the hardest part is learning the definition of an integral in terms of these limits again. But then once you know how to integrate a bunch of functions, then there's a lot of applications you can do. Um, so anyway, that's kind of a map. I think I just kind of briefly summarized pretty much everything you would learn in a typical first year calculus course. So I've kind of given you an overview of what you can expect. And I hope I've convinced you that it's not too bad. It's kind of fun. I mean, you have to get over a couple hurdles. I guess that's the main thing I wanted to emphasize when I show these slides. And I think the hurdles are the stuff in the middle, the stuff involving limits. Um, but anyway, so then limits. That's kind of the starting point for learning calculus. And like I said, limits are pretty complicated. You have to kind of learn all this stuff on the slide. I'm not even go through this whole slide, but you have to learn how to compute different kinds of limits. Once you know that, you can compute derivatives, and then it's sort of a breeze. But and then when you're learning about derivatives, this is kind of the starting point of actually doing calculus. The reason you need to learn limits in the first place is because the derivative is defined as a limit, and here's the definition. This is a definition of the derivative of any differentiable function. So even if you didn't know the rule, you could always apply this formula to figure out what it is. And so then here's a map of derivatives, and I'm not going to go through this. This is kind of a subset of the map of first year calculus I showed you, but there's a bunch of different kinds of functions you can calculate derivatives of. I didn't really talk about applications, but differential calculus, integral calculus too, has applications all over the place in all of the sciences, basically. I'd say all of modern science is based on calculus. Without calculus, we'd still be in the Middle Ages as far as science goes, I think. So thank God for Newton and Leibniz, who invented calculus and basically gave birth to modern science as we know it. And yeah, integration, integrals. I probably should have showed you something like this yesterday when I was talking about speed. If you want to calculate distance you're driving and speed is a function of time, it's just the area under this curve. And you can calculate that area by taking another limit. You do this kind of histogram thing where you start with fixed width bars. That's easy to calculate. You just add up all the areas, but then you're taking the limit as these widths of these bars goes to 0, and then you get what's called an integral. And then, like I said, there's formulas for calculus. And then you learn the fundamental theorem of calculus. That's kind of how you learn these formulas, because there's something called the fundamental theorem of calculus. There's actually two versions of it. They're written down here. I'm not going to go through this in detail, but basically to just say that integration is the opposite of differentiation. You can integrate first and then differentiate, and then you get back the original function. That's what the first law says. The second theorem says the opposite. If you integrate a derivative, you get the original function back. So anyway, and then the last thing I'm going to show you here's a map of integration. And like I said, I think integration is kind of fun. So once you know what an integral is, you learn all these rules for evaluating different kinds of integrals, and they're kind of fun, and they're all very useful. So there's a lot of different kinds of integrals that you learn how to calculate, and they all kind of come up in different contexts and in the sciences, so they're all useful. So anyway, I hope I gave you a pretty good overview of calculus, what's involved in learning it. So thank you for watching. Long live math, and I'll see you guys next time. Bye.